Find the Cummulent generating function in Poisson distribution. Also show that in Poisson distribution all components are same. So now we solve this. First we calculate Cummulent generating function of Poisson distribution. So by definition of Cummulent generating function, it is represented by k of t. Mathematically it is represented by k of t is equal to log of e m of x t. The moment generating function of Poisson distribution is that we already prove m of x t is equal to expected value of lambda e power t minus 1. So put this value of moment generating function in this equation. K of t is equal to log of e power lambda into e power t minus 1. So use the power rule for logarithm. What is the power rule? If you take the log of m power k, we multiply k with log of m. So similar operation done with this log function. Multiply power with log of e. So lambda into e power t minus 1 log of e power e. Log of e is equal to 1. So we left with lambda e power t minus 1. As you know, e power theta is equal to theta 0 over 0 factorial plus theta power 1 over 1 factorial plus theta power 2 over 2 factorial plus so on. So e power t we expand with this expression. Here is theta. Now we have in our equation t. So t power 0 over 0 factorial plus t power 1 over 1 factorial plus t square over 2 factorial plus t power 3 over 3 factorial plus so on. T power r over r factorial minus 1. This one minus 1. So t power 0 is equal to 1. Any number, for example, you have number 2. 2 power 0 is equal to 1. So any number half power 0 is equal to 1. 0 factorial is also equal to 1. So the general formula for Cummulent is, so we have here 1 plus t power 1 over 1 factorial plus t square over 2 factorial so on t power r over r factorial minus 1. So multiply lambda with whole equation. Here is 1, multiply lambda with 1, we have lambda plus lambda t power 1 over 1 factorial plus lambda t power 2 over 2 factorial plus lambda t power 3 over 3 factorial plus so on. Lambda t power r over r factorial minus lambda. Cut this minus lambda with this plus lambda. So comparing, we left with this equation. And our formula for Cummulent is k1 t1 over 1 factorial k2 t square over 2 factorial plus k3 t power 3 over 3 factorial plus k4 t power 4 over 4 factorial plus so on kr t power r over r factorial. So compare this equation with this general form of Cummulents. Comparing both equations, so we have multiply k1 with t. So here is our k1 is lambda. Here with t square our k2 is lambda, and k3 which is with t power 3 over 3 factorial is also lambda, and k4 is equal to lambda, and kr is also equal to lambda. So we proved that all Cummulents are same in Poisson distribution. If you like video, then click on like and subscribe my channel Statisticians Club. You can find complete distributions, proof of the distribution of discrete uniform distribution, Bernoulli distribution, binomial distribution and Poisson distribution. I also made their playlist. You can find on my channel Statisticians Club. Thanks for watching.